The James Webb Space Telescope, a marvel of engineering and scientific ambition, represents humanity's relentless pursuit to understand the cosmos. Also called JWST, is not just an ordinary telescope, it is a giant, sophisticated observatory in space, designed to peer into the deepest realms of the universe. Scientists and engineers from around the globe collaborated to build it, pushing the boundaries of what's technologically possible, to help us see things in the universe that we could never see before, unlocking cosmic secrets hidden for billions of years. It is much bigger and better, a true leap forward in space-based observation, than older space telescopes like Hubble, which revolutionized our understanding of the cosmos. Webb can look deeper into space, capturing light that has traveled for billions of years and farther back in time, allowing us to witness the universe in its infancy and observe the formation of the first galaxies. But why did we need a new telescope, especially one as complex and expensive as the James Webb? The universe is full of secrets, and many of them are hidden behind cosmic dust and vast distances. Hubble helped us answer many questions, revealing the beauty and complexity of galaxies, nebulae, and other celestial objects, but it also found new mysteries, sparking even more questions about the nature of dark matter, dark energy, and the evolution of the universe. To solve them, we needed a better tool, one capable of seeing beyond the limitations of previous telescopes. That is what Webb became, a super eye in the sky, designed to observe infrared light, which is invisible to the human eye and allows us to peer through cosmic dust. Launched on December 25, 2021, a momentous day for science and exploration, the James Webb Space Telescope traveled far from Earth, embarking on a journey to its final destination in the vast expanse of space. It now orbits the Sun, about 1 million miles away from us, at a special location called the Lagrange Point 2, or L2, where it remains in a stable orbit. From there, shielded from the light and heat of the Earth and Sun, it takes clear pictures of stars, capturing their brilliance and revealing their secrets, galaxies, unveiling their intricate structures and the processes that drive their evolution, and planets, studying their atmospheres and searching for signs of life beyond Earth. Webb is important because it lets us look, with unprecedented clarity and detail, at the universe in a new way, opening up new avenues for scientific discovery and exploration. It helps us see things that are too faint, too distant, or too far for other telescopes, pushing the boundaries of our knowledge and understanding of the cosmos. Thanks to Webb, we are now making discoveries, rewriting textbooks, and inspiring future generations of scientists and explorers that change how we think about space and our place in it, forever altering our perspective on the universe and our existence within it. The James Webb Space Telescope represents a monumental leap in our ability to observe the cosmos. It's not just another telescope, it's a sophisticated observatory designed to unravel some of the universe's greatest mysteries. It's special for many reasons, setting it apart from its predecessors and opening up new frontiers in astronomical research. Its unique design and advanced technology allow it to peer deeper into space and further back in time than ever before. First, its mirror is very large, a critical feature that dictates its light-gathering power and ability to resolve fine details in distant objects. About 6.5 meters wide, this impressive size dwarfs previous space telescopes, providing a significantly larger collecting area. This big mirror lets it collect lots of light, enabling it to detect incredibly faint signals from the farthest reaches of the universe. From faraway objects, galaxies born shortly after the Big Bang, and other celestial bodies hidden from our view by vast cosmic distances. More light means Webb can see things that are very dim and distant, pushing the boundaries of our observational capabilities and revealing aspects of the cosmos previously inaccessible. Webb also uses special cameras and tools that can detect infrared light, a crucial capability for peering through cosmic dust and observing the red-shifted light from the earliest stars and galaxies. Infrared is light we cannot see with our eyes, but many things in space shine brightly in this kind of light, making infrared observations essential for understanding the composition, temperature, and motion of celestial objects. By using infrared, Webb can look through clouds of dust and see hidden objects like newborn stars, which are often shrouded in the very dust clouds from which they formed. Another reason Webb is important is because it can look back in time, offering us a glimpse into the universe's infancy and the formation of the first galaxies. Light takes a long time to travel across space. When Webb looks at distant galaxies, It sees them as they were billions of years ago, their light having journeyed across vast cosmic distances to reach us. This is like looking at the universe's old family photo album, allowing us to witness the evolution of galaxies and the formation of the first stars. Building Webb took a long time, over 20 years of work by scientists from all over the world, representing a truly global effort to push the boundaries of human knowledge and explore the cosmos. They made sure every part worked perfectly, subjecting the telescope to rigorous testing to ensure its flawless operation in the harsh environment of space. Now all their careful planning is helping us make amazing discoveries, revolutionizing our understanding of the universe and inspiring future generations of scientists and explorers. One of the first things Webb did was give us the deepest, clearest view of the universe ever seen. Its first images showed thousands of galaxies in a tiny patch of sky. Some of these galaxies are so far away, their light started traveling to us just a few 100 million years after the Big Bang. These first pictures were stunning. They showed bright spiral galaxies, odd-shaped galaxies, and even galaxies that are merging together. Scientists could see details they had never seen before, even in galaxies that are billions of light-years away. One special image, called Webb's first deep field, became famous. It showed a cluster of galaxies bending the light from galaxies even farther behind them. This bending, called gravitational lensing, acts like a giant magnifying glass in space. Thanks to these first views, scientists quickly realized that there were more galaxies and more surprises waiting to be discovered. The James Webb Space Telescope, with its unparalleled infrared capabilities, has opened a new window into the distant universe. Webb has helped us find some of the oldest and most distant galaxies ever seen, pushing the boundaries of our cosmic understanding. These are truly relics from the early universe. These galaxies formed just a few 100 million years after the universe began, a period often referred to as the cosmic dawn. This is when the first stars and galaxies ignited the darkness, which is very early in cosmic history. It's like looking back at the infancy of the cosmos, witnessing the very first building blocks of everything we see today. By studying them, with the incredible precision that Webb offers, we learn how galaxies like our own Milky Way started and changed over time. We can trace the evolutionary path from these primordial structures to the grand spiral galaxies we observe in the present day. Some of Webb's discoveries showed that these early galaxies, contrary to previous assumptions, are brighter and more active than scientists expected. This challenges existing models of galaxy formation and evolution. They are full of young stars and are growing quickly, undergoing intense periods of star formation. It's a period of rapid development and transformation. This was a surprise, a genuine revelation that has reshaped our understanding of the early universe. Because before Webb, we thought the first galaxies would be smaller and dimmer. We envisioned them as more modest and less energetic systems. Webb also showed that galaxies come in many different shapes and sizes, even in the early universe. There's a remarkable diversity in their morphology. Some are round, exhibiting a smooth, elliptical shape. Some are flat, displaying the characteristic disc-like structure of spiral galaxies. And others look like they are being stretched or pulled apart, showcasing the chaotic nature of galactic interactions. These new views help scientists understand, in greater detail than ever before, how galaxies collide and grow larger through gravitational interactions and mergers. Studying these faraway galaxies helps answer big questions, fundamental inquiries that have puzzled astronomers for decades. How did the universe change after the Big Bang? What were the conditions like in those early epochs? How did galaxies form and become what they are today? What processes shaped their evolution into the diverse structures we observe in the present-day universe? One of Webb's most exciting jobs is to study exoplanets, planets that orbit other stars. Scientists want to know if these worlds might be like Earth, or even if they could support life. Webb looks at the atmospheres of these planets by watching how their star's light changes as the planets pass in front. With its powerful infrared eyes, Webb has already found signs of water, carbon dioxide, and other important chemicals in exoplanet atmospheres. On a planet called WASP-39b, Webb saw clear signs of water vapor. On other planets, it found clouds, haze, and even possible signs of weather. These discoveries are important because they tell us what exoplanets are made of. They also help us guess if any of these distant worlds might be friendly to life. Webb can even study rocky planets that are closer in size to Earth. This gives us hope that one day we might find a world with air and water, just like home. Stars are born in giant clouds of gas and dust. Before Webb, it was hard to see inside these clouds because dust blocks most of the light. But you know, Webb's infrared vision can see through the dust, showing us the secret places where stars are born. Thanks to Webb, scientists have seen baby stars forming, surrounded by disks of gas and dust. Some of these disks may later become planets. This helps us understand how our own sun and solar system began billions of years ago. Webb has also studied old stars and the way they die. Some stars explode as supernovas, while others slowly fade away. By watching these events, Webb gives us clues about how the elements that make up our planet and our bodies are created in space. Looking at stars at every stage of life, from birth to death, helps us understand the life cycle of the universe itself. Black holes are some of the strangest things in space. They are so heavy, not even light can escape them. Webb has powerful tools to study black holes, especially the huge ones in the centers of galaxies. Webb can see the hot gas and dust swirling around black holes. It can also measure how fast this material moves. In some galaxies, Webb found supermassive black holes that are millions or even billions of times heavier than our sun. By studying these black holes, Webb helps us learn how they grow and how they affect the galaxies around them. Sometimes black holes shoot out jets of energy and matter, changing their whole galaxy. Webb's new data is helping scientists solve old mysteries about where black holes come from and how they shape the universe. Some of Webb's discoveries have surprised even the experts. For example, Webb found galaxies that were much bigger and older than anyone expected, not long after the Big Bang. This has made scientists rethink how fast stars and galaxies can grow. Webb has also seen weird patterns in the atmospheres of some exoplanets. For example, some planets have strange clouds made of sand or glass. Others have days where it rains metals, not water. These findings show us just how different other worlds can be. Another surprise came from Webb's study of star-forming clouds. In some places, new stars seem to form in groups or clusters, while in others they are spread out. This changes what we thought about how stars are born. These surprises remind us that the universe is always more interesting and strange than we expect. New questions appear every time we find an answer. The James Webb Space Telescope has changed the way we see the universe. Its discoveries help us answer big questions. Where did we come from? How did the universe begin? Are we alone in the cosmos? Each answer makes us feel more connected to the stars. Webb's work is not just for scientists. Its pictures and discoveries inspire people all over the world. They show us that there is so much more to learn, and that anyone, anywhere, can be curious about space. Learning about the universe also helps us here on Earth. New ideas from space research often lead to better technology and new inventions. By exploring space, we become better problem solvers and dreamers. In the end, the James Webb Space Telescope reminds us that we are part of a vast, beautiful universe. Its discoveries help us understand our place in the cosmos and the endless possibilities that lie ahead.